one. Hello, everyone. Welcome back to our YouTube channel, Becoming a ROS Developer. My name is Rodrigo, and today we have one of our students, Mariem, who has completed the course ROS 2 Navigation in 5 days. And at the end of this course, you can present a project and implement it on a real robot. And this will be autonomous navigation. So this is what we will be seeing here today from Mariem. So hello, Mariem. How are you?
Hello.
So yes, whenever you want, you can just start sharing your screen and show us what you've done with your project.
Okay.
Awesome. We can see your screen
Can you
now.
see my screen? Okay.
Yes.
So I will start demonstrating how my project works. So here I have ROS2. I will open the configuration that I saved.
You have a good eye.
Yeah, it's very small screen. Okay. Then I will start the localization. In the localization launch file, I also have the map server. That's why it starts also the map.
Right.
Okay, I need to give it an initial pause. Okay.
Oh, nice. Is the robot there right now?
Okay. It's here.
Okay. So no. Oh no, yeah, it is. It is. Sorry.
Yeah, it's there. Okay, I will start the path planning launch file. Okay, now I will show you my my action. This one will move the robot to a position that I have saved under the name corner one.
Okay.
Oh wow.
Maybe the name is different.
I'm not sure. I will check it just right now. Okay, so there. I will try the second one.
Try sourcing your install here. So before, oh, you did it.
Yeah.
Okay. So maybe it's not finding it. Oh, corner one, two.
It's not finding 1, 2, but I'm writing 2.
Oh, there we go. That was weird.
It was 1, 2. Okay, let's see it here.
Oh, no, it's already moving, huh?
Yeah.
So it's trying to plan. Can we see what the robot is doing? It looks like it's
stuck somewhere. Okay.
So I have an idea, Mariem. You can kill 704 and 701 because 702, 704 is the action client. So you can kill this and this, So 701 and 704.
Okay.
Yeah. And you'll have to reload Arvis, but move it away from the wall a little bit. I don't like that it's against the wall, and I'm pretty sure you mislocalized it. I'll show you. So yeah, move
Uh,
it back. Right there is fine. That way the obstacle, the layers, the inflation layers, it won't be on top of one or
yeah.
something that will prevent it. That's my guess that was happening.
Okay, I understand you.
So now it should actually be better localized. So you might have to run Arvis again because it doesn't like this.
Yeah, I think I gave a bad initial position.
Mm-hmm. And since the map server, yes, exactly. Yeah, you get it. Yeah, so now it's where you said, and it's pointing towards your left, I believe. Yeah.
Should be here.
Now twist it a little bit to make sure we are localizing correctly. Like twist one way for a while and then twist the other. Yeah, you see? And then twist the other, and it does a really good job as well. Because that's the best way I've found, just twisting both ways. It kind of localizes itself better.
Okay.
Just a little bit. Then they converge even more. All right, now we're localized. And before it was like somewhere else, right? So I think that was an issue. So now there we go. Oh, nice. And it did it so
Yeah,
well. And the robot actually went there, correct? Yeah, otherwise we wouldn't be seeing this, but I just want to.
it should.
Awesome. 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 Do you have another spot we can send it to?
Yeah, I have this paid stream.
Uh-huh.
Yeah.
Very smooth. Yeah, yeah. So you understand what was I think what was happening was that two things. It was localized somewhere else, and it was right against the wall. So when you launch the path planner, let's say it was localized correctly, it was like I'm somewhere that I shouldn't be. I'm like in that inflation zone. So all right, awesome. This is great. We now see the application. So could you just explain us a little bit how you've solved each section?
Okay. So I will go through the 4 sections for this project. First, we have the mapping. Okay, I think this is. So here we have the output of the TF2 tools.
Mm-hmm.
We have a graph that details the relationships and the data transmission rates between the frames. We have the DOM frame, which is connected to base footprint. Then we have base link, which is connected to IMU link, base scan, and the wheel links. Okay, then I created the project mapping package. I have the this launch file which launches 2 nodes for the SLAM. One for running the cartographer node with this configuration file that I specify, and the other one for generating an occupancy grid, and it sets up the configuration directory dynamically based on the project mapping packages shared directory, and it uses the .loa configuration file.
Mm-hmm.
This one is this configuration file. It includes using one laser scan, enabling odometry, 2D projection, setting the timeouts and the publishing periods for different operations. Okay, then I started that node and I created a map of the environment that I saved and I used later, like I did in the demo.
Mm-hmm.
Then I have this launch file in order to serve the map to other apps. Here I specify the path to the map file.
Mm-hmm.
And I have the map server node, also the lifecycle manager, which manages the transitions between nodes. The next section is the localization. So here we have the launch file for the localization. I included here the node for the map server because sometimes I needed it to be included in the localization to not start two launch files at the same time.
Mm-hmm.
Makes sense.
Yeah.
Okay, then I have the AMCL node and always the lifecycle manager to manage the transitions between nodes. This one is the AMCL configuration file. Okay, this is the output. Here we can see the laser scan. It gives an indication if the robot is localized correctly. And also this is when starting with the dispersed particles, and then when I move it around a little bit, they get grouped. Okay, then I saved some spots in a YAML file. So for this, I did the echo command on the topic AMCL pose, and I manually type those values that I see in this file.
Okay.
Okay, but then what we want is we want to make this to automate this with creating a service that will save the space for us. So first, I needed the definition of this save spot interface. As a request, we'll have a label, which is what we designate the spot with. And as a response, I will get a Boolean which says whether the navigation was successful or not, and a message like the spot was saved or something. But here I had a problem when I did this under the project localization package, which is Python created.
Mm-hmm.
So I did it the old way, the way that I did in the ROS2 basics, which is I created another package, custom interfaces, which is built with M and C make, and this way it worked. Okay, then I have this script. It listens for poses under AMCL pose. It stores them in a dictionary with the labels that are provided in the command. And when the service is called with the label and, it writes all the saved poses into spots.txt. And this is the launch file, and here we have an example of recording a position named initial. Then when calling the service with and, they are saved here under spots.txt.
Mm-hmm.
The next section is the path planning. Here I have parts of the launch file. I have 5 nodes. The nav2 controller, planner, behavior server, behavior tree navigator, and the lifecycle manager. And I have the configuration files, which most of them are from the provided in the course.
Mm-hmm.
Uh, then, uh, then I launched this file, and I specify the position I want the robot to move to with rviz to the goal pose, and it actually moves there. The final section is the ROS2 node that interacts with nav2. So here we record the spots, but in a different way. We want to save the location of a marked point from Arvis. So for this, we use initial post topic to receive the position and orientation, and we
Ah,
write them also in a YAML file. Uh, okay, here also I needed some converting the message into a something uh, like the one specified in the instructions. Then here I have the output of the recorded positions. Oh, this one that I was talking about, the format of the parameter file.
oh,
Uh, this is how they specified it in the instructions, so I needed to change that. Then I have this action client for the navigate to pose, which is part of the nav2 stack. Uh, and this moves the robot to the a position located in the saved YAML file. And this is the output for corner 1, corner 2, and pedestrian positions. That's the end of it.
awesome. Really, really nice, Miriam. Congratulations.
Thank you.
I really liked how we went through the process together here and identified some issues which helped me clarify and understand better your project. So, congratulations, first of all.
Thank
Really,
you.
really nice project. It looks like you put in a lot of work. And so, let me ask you some questions. Let me make some comments actually. Uh, the first thing, it's a recommendation, and I noticed because I make the same mistake as you. Uh, you have to choose what launch file extension you're gonna use. Uh,
Mm.
yeah, I saw you try launch.py and then delete the .py because you probably forgot because you've probably been using ROS1 and sort of get confused with that. That's
Yeah.
just an organizational thing, and I noticed that that happened to you. Uh, but that's the first one. And the next comment I have is has to do with the life cycle managers and what nodes you're running and a little bit of how the map server works. So I noticed you mentioned, I put the map server again here because, you probably weren't seeing it in Arvis all the time, right? Was that what your issue was? Yeah,
Mhm.
so you were running the server, you were running things and you wanted to see the map, but then sometimes you launched things again and it wasn't there. So you were like, come on, where is it? So you just kind of put it everywhere to sort of deal with that problem. All right.
Mm.
So the reason why that is because uh, the topic of the map topic, right? So the topic in which the map, the actual image of the map, is published under, is published a little bit different than most other topics. Why is that? Because it's kind of heavy and it also only publishes once. When you run the map server, you publish it once. That's it. So that's one message. That's why if something is not running, like Arvis, and then you launch it, it won't catch it. It won't automatically detect, oh, there's the map server here, so I need it again. Give it to me so I can see it. Uh, so that's actually has to do with the QoS of ROS2, basically. And it basically means, yes, I need to serve it every time I need it. So that's why you weren't seeing it. You don't need it everywhere because, for example, navigation will detect it that it has been served by the map server. You won't see it with Arvis, but it will work. But of course, it will be difficult to understand to what's going on. So that's the reason with the map server.
I
And then
understand.
and then the other thing I noticed is in one of your screenshots in the life cycle manager, you know how at the end you tell the life cycle which nodes to run. And this is specific to what are called life cycle managed nodes, in which nav2 works under there, under life cycle management, because that's how they built it. So I saw that in every lifecycle manager, you were trying to run every node. So starting with the map server, AMCL, and then moving forward. That's a little bit of an overkill, and it actually might give you problems. I'm surprised you didn't have any, but maybe you did, and you did understand why. So what I do all the time, because this can get really confusing, from all the nodes you're launching, all the configuration parameters you're doing. So what I do all the time with these things, especially with nav2, I do this all the time. First, I have a launch for my map server, and it only launches my map server, and I can run it however many times I want. All I know is it's just gonna kind of spit out my map in order for other things to catch it. Then I run the AMCL, the localization part. And in that life cycle, the life cycle node that you have to put at the end there and that launch, I actually name it differently. So it's called life cycle manager _ localization. And then I only run my AMCL in there. And yeah, that's it. That's the only thing that life cycle manager is in charge of managing. And then in the path planner, I do the same, except now I run only the controller server, the behavior server, all those last, I think it's 4 or 5, BT navigator, and the other, I forget. But that way I can separate them in my head and sort of understand which, what each launch is separate in my head. And that helps me out a lot with debugging later down the road. So that's just another thing I noticed. But other than that, Mariem, that was really, really nice behavior, really tuned. I didn't see it get lost. In the beginning we did, but because, we kind of started with the wall right here. So that's going to have an issue no matter what. Maybe for that reason, in this scenario, for example, you could adapt a little bit the behavior node, the recoveries node, so it would start spinning right away and maybe get out of it. But okay, the simple solution is just get out of it a little bit. But what I was trying to say is that the movement told me that you really spent your time configuring it in order for it to not get lost, to not run into obstacles, things like that. So that was really, really nice to see as well. And I also really liked that you, for example, for the save recorder, the spot recorder, the spot recorder saver, I guess. I really liked how you explained it, because that's how it should be and how I do it personally. You said, how do I do it? Well, I echo the AMCL post and I see what it is, and then I put that into a YARN file. That's the first step, because that's what you then want to make it automatic, right? You want to make that with the service. So I really like that process, and I think that helps you understand as well. Also loved that you talked about you were doing your custom service, and then you put it in the same package, instead of doing a separate custom interfaces. That showed you a little bit of the pain of custom interfaces, and the reason why the best practice, you can make it work like you did, but the best practice is to do your second step, to do a package which is separate, so then every other package can look at that and find it and not have that annoying, I can't find my service even though it's right there, So I really like that as well. And that's it. Other than that, I mean, it's a really nice project. So congratulations, Mariem.
Thank you.
All right. So yeah, that is it for us, guys. So let me change here my screen to myself only. And yes, this is what you can do when you're done with your project. You can with your course. I'm sorry. You can complete the project and then come present it in order to get a certificate from us and to showcase all the learnings that you've done. So I really encourage everyone to do what Mariem did here and to keep pushing your ROS learning. And that's it for us, guys. Mariem, thank you again one more time, and we hope to see you again soon.
Thank you.
All right, guys. We'll see you later. Bye-bye. Okay, Mariem, we are done. Awesome.